Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to help you out with some of these AC circuit problems in your homework. One of the things I want to point out here is in number 5 where it says for the circuit diagram shown, draw a circuit, label the highest potential red. I really meant to put the word label the constant potentials, just like I did in my video over examples of AC circuits. But anyway, so what you want to do here with this is, all right, take this picture and draw the circuit diagram for it. Now, hopefully you've seen my video, you've seen what the circuit diagrams look like. Now, this stuff right here, this 170 volt peak at 60 hertz, that's telling you, hopefully, that you recognize that that is the voltage of the US power grid. So when you go home tonight, if you're watching this anywhere in America and you plug in something, right, that's the voltage waveform basically that you're getting access to. Now, oddly enough, which of these numbers are important in the problem? Neither of them. Okay, when you do any calculations, you always use what's called the RMS voltage, which you get by taking the max and dividing by √2. If you do that, in this example, you're going to get 120 volts. Okay, so this is the voltage you're going to use in any calculations. So draw the circuit diagram over here, just like I did in my example videos. Put a resistor here for this. Now that one right there, you're given the resistance, you're given the current, not the power, right? Ohm's law, voltage equals current times resistance, can be applied to this. And the voltage is 120 volts and the resistance is given, and there's how you find the current. Really almost nothing to it. All right, for number 6. Okay, so here are a pair of bulbs and they're wired in series. Now you would really never do that in an AC circuit, but I just wanted to give you folks a little bit of practice with it anyway, I guess. And here's the deal. When light bulbs or when resistors are wired in series like this, the effect is cumulative. So if you have 10 ohms of resistance here and 20 ohms of resistance here, guess what? You can replace them with a single resistor in your picture and use 30 ohms, the sum of the two. Finish the picture up. Use the appropriate voltage here. Again, just like the previous, you're not going to use the 170, right? You're going to use the RMS voltage, which is 120 volts. And then find the average current. So really this problem is no different than the previous one. Okay, so number 7 here, this is a parallel circuit. Draw the circuit diagram, and again, just go look at my example I drew in, that I did for you folks on AC circuits. I would color code the potentials. I like to use red, for one potential, and I just leave the other one black. All right, and that will hopefully show you that the voltage is across here and here is the same as here. Now here, let's see, this one says 120 volts, 60 hertz, and the 120 is not labeled. The intention here was that was the RMS voltage, so go ahead and just use the 120. Now it says something about a circuit breaker here. The circuit breaker would be in this part of the circuit. I didn't actually put it in the picture, and you don't really need to in your example either, but just draw your circuit diagram, find your currents in this branch, and then in this branch, and then the current in this branch, all right, it's cumulative, will be the sum of the two, and then see if that current is bigger than 15. If the answer is yes, then it would trip the breaker, and if not, then the answer is no. Okay, moving on. Similar type of question, it's just here you're given powers instead of resistors. So I did an example just like that. Hopefully you should have no trouble with that. But make sure you draw this a good circuit diagram replacing the light bulbs with the resistor symbol. Okay. Nine. Okay, we have a 700 watt toaster ran from a standard US source here. i.e. a standard American outlet. Not sure why I've got a 1-1 there, but anyway, so what you want to do here is draw a simple circuit, put just the toaster in, put a resistor for it. This is telling us it's a standard US source, and remember the voltage for that source, the RMS voltage is 120 volts. That's what you want to use in any of your calculations. Okay, number 10. Let's see, how many 60-watt bulbs can you run off a single circuit before tripping a 15-amp breaker? So, draw a simple circuit showing one bulb. Ran off of a 120-volt source. Calculate the current per bulb, and then remember that when you're talking about in parallel, the current's additive. The current through the breaker, right? When you add 2 bulbs, you'll have twice the current. 3 bulbs, 3 times the current, and so forth. And just see how many bulbs you can get before you hit 15 amps. All right, 11. Explain in great detail why household circuits are wired in parallel. So I'm not going to do that for you. I've got videos on it, or you can look in your textbook. It'll be described in there, but I want you to actually write it down and explain it, okay? That's probably enough here. That'll get you through quite a few problems. Have a great day.